a minute. There we go. Okay, so we should be getting live in a minute. Hi, Phil. Hello, Alberto. Welcome, everybody. If it's okay with you guys, I'm gonna start off with a poll while we're waiting for folks to join. And that poll is, there we go, YouTube's ready to go. That poll is about observing. So I wanted to, first of all, we talked about it last time, Venus and the Pleiades coming together, the conjunction. And so I wanted to see if anybody had gotten the chance to go out and see that. And if anybody else has just in general been out to observe since then. So the poll is up and ready to go. If you guys want to vote so we get an idea of what's going on there. Chris, did you get to see it?
I did. I saw it the night before. It was cloudy on the Friday night.
Oh, shoot.
Yeah.
Oh, it's still cool.
But they were still close enough that I could fit them both in the field of view of my big telescope, which was great.
Ooh, perfect. And I meant to, maybe I'll do that now. So one of our members was using, so we have this robotic telescope in California, and one of our members, Dan Meek, was using it to take photos of Pleiades and Venus. Of course, you can't really fit them, or you can't take a good photo of them in a telescope because the Pleiades are so large, especially with our telescope, just you don't get the whole thing. So we have a camera on the back, and I'm going to find those photos just to show the progression, because he did it 3 nights in a row, which is really great.
Ah, nice.
Yeah,
make a GIF.
Yeah, exactly. We can see the movement. Let me send out. Let's send it. Do you say GIF? I usually say GIF.
GIF.
It's so divisive. Oh. All right, let me find the screen. Okay, so there is the first night, and then the second night, and the third night.
Cool.
Yeah, it was really nice. Good conditions. Then it got cloudy on the one after that. But what we did have, actually, we had somebody from our group here, Kai K, I'm not entirely sure how to pronounce your name, I apologize, send in photos as well from when they were out observing. So I'm going to open those and show those too. So there's the first one. Pretty good work, I'd say.
Yeah.
So you can see the Pleiades there. And the best part, I don't actually remember the names of these stars. Do you know the names of the 2 stars up here, Chris?
Alcyone is the one to the right of Venus, and Pleione and Atlas are the 2 above. There's actually 2 above. So
Kay was looking at Stellarium to figure out that it was almost a perfect right angle would be formed by those 2 stars in Venus.
Yep.
And it was. Hooray for observations matching predictions. And then there's the following night. Also a wonderful photo.
So the pair of stars, the dim and the brighter and the dim one closest to Venus.
In this photo?
Yeah. So below Venus, the 2 stars. Those are the parents of the 7 sisters. That's Atlas and Pleione.
Oh, very cool.
And so the 7 sisters are the other group.
Oh, I always wondered. And tell us, Chris, I'm going to close the poll briefly.
I'm not sure about the number 7.
I know, I was going to say,
it varies a little bit.
How many of those can we actually see?
Yeah. I think most people would count Atlas and Pleione among the 7, so kind of the 6 sisters, but
it's hard to see all of them. They used to use it as an eye test, if I recall correctly, to see how many you could see, right?
Some people have gone out observing. Yes, excellent.
Yay! Oh, I'm so glad. 64% have gone out observing, and only 10% have just said straight up, no, I refuse, which is great.
Waiting for better weather, maybe.
Yeah, this is really not always the best season. All right, lots of folks saying cloudy. Some folks saying solar observing. Oh, that's nice.
Yeah.
Alrighty. So it's 4 minutes after. Sorry for taking so long.
Right. Let's start sharing my screen here.
I'm gonna say 2 quick things before we get officially started.
Okay.
Actually 3. One is that we have a member who's volunteering in the chat to help us out. So if you see Blake Nancaro in the chat, he's going to be answering some of the technical questions that are coming through. So if you have really technical questions, like things like how do you find the field of view, or stuff that is a little specific, that'll be in the chat. And Blake will be there to help out.
Blake's another Stellarium power user. He and I geek out all the time about the latest settings and everything. So
that's perfect. He's a good guy. The 2 things, I do want to announce the winner of our handbook draw. And that winner is, we don't have people to do a drum roll when it's virtual. The winner is Noah Walters Beacock. So thank you so much, Noah. I'm going to email you shortly so I can ask for your mailing address and we'll get it shipped out to you. And the very last thing is we're doing a bit of a rebrand on Homebound Astronomy. So we had chosen the name Homebound Astronomy before we had gotten our legs. And in the 2 sessions we've had so far, we have found out that Chris is a giant nerd. And having already referenced Harry Potter, you've already referenced Daleks from Doctor Who. This time we're going with another reference. We're going to change the name of Homebound Astronomy to, Chris?
The Insider's Guide to the Galaxy.
Perfect. So we're going to see how many references we can get to the Hitchhiker's Guide to the Galaxy in this episode. That's your challenge, Chris.
It's been a while for me, so that's up to the chat.
It sounds good. Alrighty, and now we have calls for the topic for today. So Chris, over to you.
All right, I'm going to share my screen and bring us up to here. Here we go. Can everybody see my screen okay?
Yeah, I can anyway.
All right, so I've got Stellarium up and running now. I will mention a couple of other settings that as we go each time, I'll try to build your Stellarium muscles and give you a few more sort of power tips. So one thing that I like to have Stellarium revealing the constellations when I first boot it up. So what I do there is as I go down and I hit the icons here, the first and second, the one right below where it says Earth Toronto. So this one is for the stick figures and this one is for the labels. So I make that one come on, and then I'll go over to the configuration window F2 and I'll save those settings. And that way, every time I start the program, it's there. Now, we had some talk the other day about comets and whether or not a particular comet was visible in Stellarium. And I've got good news, bad news. So the good news is I'm going to show you how to make sure that your Stellarium has the ability to plot the positions of comets. But the bad news is that we just got word yesterday that we think Comet Atlas, the big one we're all waiting for, might be fizzling. So its core, it may have flared too fast, too soon, and is breaking up. We're not sure, but we're waiting for confirmation. And unfortunately, the moon is full all around the world right now. So it hinders our ability to really observe that comet. But I'd say that the news isn't great as far as the Comet Atlas goes. But there are a total of 3 comets up in the night sky. So they're sort of binocular comets, dimish comets right now. But we're always have our fingers crossed for some new comet to show up. So what I'm going to do is if you stay in this config menu, go into plugins. And I did touch on this the other day, but I'm just going to refresh here. I go over it again. Scroll down to where it says Solar System Editor. Click on where it says Configure. And then you get a new little box popping up. And then you want to click to the tab that says Solar System. And go down where it says Import Orbital Elements. So click on that. And now the third box pops up. And what you can do is you can choose between asteroids and comets. I'm going to choose comets. And then I'm going to click on here where it says Select a Bookmark. Go over to this little arrow. And down here it says MPC's List of Observable Comets. This is the Minor Planet Center, MPC. List of observable comets. So choose that and then go down and click Get Orbital Elements. And you'll see depending on how fast or slow your machine is. Then you can come in here and you can just say Mark All and add them. And it'll go and crunch a little bit. Download the information. Just takes a couple seconds and then it's done. And you can head on in here and close these all off. So now if I go up to tonight's sky and I go into my search menu here, we'll just test this out. And so I actually typed this in the other day and it remembered it. So the comet that's fizzling perhaps is C/2019 Y4 Atlas. You don't have to type the whole name in. Then you can click search and it'll show you that it's in Stellarium now and in the sky. And the other thing you can do, a neat little thing, is you can go down here where it says Astronomical Calculations window. You can open that one up. And there's a bunch of tools in here we won't get into today, but if you click on the tab that says Ephemeris, and you go in here where it says Vesta right now and type that C 2019 Y4 Atlas, then you can actually plot the path of the comet across the sky, and you can set how many hour intervals you want. So you could do it every day or every half day or every quarter day. So if I say every 6 hours, and I say calculate, then I'll just put this out of the way. Then it's drawing me the path of the comet through the sky over the next, I didn't mention, but you can set the date. So I've got from April 7th to May 7th, over a month. And you could set this down to say 1 week's worth or something. If you sort of zoom in, every dot represents 6 hours of travel. So you can see comets move across the stars pretty quickly. That's one of the reasons the early comet hunters used to look for things that were moving and know that they were comets. And then to get rid of that path, you just clean up and you're done. You can start fresh. So that's my trick for that, for doing comets. But with the big supermoon, so-called pink supermoon happening tonight, I thought I'd focus on the moon for this session and show you some really fun simulations that you can do with Stellarium to learn about how the moon works, the moon's motion, and some of the objects on it. So what I'm going to do here is center my sky to the south. I'm going to advance later tonight. And the moon is orbiting around the Earth, of course, and when the moon reaches a position that's roughly opposite the Earth opposite the sun in the sky, astronomers call that expression when three objects are in a line with each other. It's a syzygy. And so the moon is always at a syzygy when it's full. And that means that as the sun goes down, the moon comes up, the full moon comes up. And what I'm going to do is I'm just going to get rid of my trees and stuff. I'm going to go to landscape and set my horizon to 0. And you can see that if I wind the time back a few minutes. Then I'll just zoom out a little bit. I've got the moon coming up as the sun goes down. So the full moon always comes up as the sun rises because it's opposite the sun and it's called a syzygy. Now, the moon's orbit around the Earth is elliptical, and that means that it spends some of its time closer to the Earth at perigee, and that comes from the word peri, meaning close, and g for geo, meaning the Earth. And then 2 weeks later, it's at apogee, which is afar, far from the Earth. And this happens at tonight's full moon is the biggest and brightest moon of the 2020. It's full within hours of it being also at perigee. And so that's why we call it a supermoon. Now, a supermoon is not an astronomy term. It was actually coined by an astrologer, but it's become used in the media a lot. So astronomers are better to join them than beat them. So we're okay with using a term that gets people interested in looking up and heading outside. Now, the term pink moon does not refer to its color, obviously. It refers to the fact that around this time of year, we get names like pink moon, sprouting grass moon, egg moon, fish moon. They all have to do with what's going on in Mother Nature around this time of the year. And of course, the moon can be full at various times of the month of April, but generally any time a moon is full in April, it gets some of those nicknames. And the indigenous peoples around the world many of them have special names for the full moon as well. I mentioned in my skylights this week that the Ojibwe people call the full moon in April the Iskigazimijige Giizis. I've said that terribly, but it translates roughly to the maple sap boiling moon for obvious reasons. So if you want to head over to the skylights, you can read a few of those special names that are used by some of the people who've been looking at the moon for millennia before modern times. So let's zoom in on the moon a little bit here. I'm just going to get rid of this meteor shower symbol that's beside it. Now here's a trick you can do tonight when you go outside. So the moon's going to be coming up at sunset. So here we are on April 7th, and my information panel here says that the moon's going to rise at 1936 in the Toronto area, so about 7:36 p.m. And what you can do is you can take your fist, hold it at arm's length, pop up your pinky finger, close one eye, and you can cover the moon with your pinky fingertip. And that works no matter how old you are. Even if you're a little wee person, your finger is still big enough to cover a full moon. Now, when you see it looking enormous, that's an optical illusion. It's always the same size. It's about half a degree across in the sky. And you're generally speaking, your pinky fingernail is a slightly more than half a degree.
Why does it end up looking so huge when it's by the horizon?
Yeah, there's a term for it. I haven't got it on the tip of my tongue on the phenomenon, but it looks bigger when you're seeing it in relation to a landscape.
Oh, makes sense.
And then when it's smaller, when it disappears above the landscape and it's sort of alone in the sky, it'd look a little different. The other thing is I want to mention is it's worth heading out and looking at the full moon. I'm just going to bring this over here and show you this diagram that I use in my skylights. And if you want to go to the skylights and right click on the picture, you can download it and save it to your hard drive, and it'll be bigger. It'll be a bigger resolution if you download it to your local machine. And so what I've got here is I've got yellow labels naming all the mare. The mare are actually ancient basins that have been blasted or excavated on the near side of the moon and later flooded with heavy, dark, iron-rich basalt that makes them a dark color. So and you can have, big regional ones, and you can also have little sort of mini maria, such as Grimaldi over here, and the crater. It's a crater, it's a mare. We're not, it's sort of a bit of both, but you can see Plato is right here. Mare Tranquillitatis, if you look with your unaided eyes at the moon tonight, and any moon, you can notice that the color of Mare Tranquillitatis is darker and bluer than the other mare. And that's because the basalt that flooded and filled that basin was enriched in titanium. Ooh. And so it expresses itself as a bluer, darker color. And that's one of the reasons why Mare Tranquillitatis was chosen as the site for Apollo 11. So the red digits, the red numerals here, are the Apollo landing sites. You can see that Apollo 11 was sent to near the southern edge of Mare Tranquillitatis. It was also chosen at that location because it was near the sort of equator and near the center of the moon. And because it's near the equator, the orbital dynamics were simpler and easier to achieve accuracy. So the other later missions you can see went farther north and different distances away. So that's the Apollo 11 landing site. And you can see it was also sent to the Mare Tranquillitatis because it's a younger, smoother, flatter site, safer for landing a lunar module on for the first time. And by the time they did 12, they were still in a mare. And then 13 never made it. 14 went to where 13 was heading. And then you can see that by the time they get to 15, 16, and 17, they're getting into very sort of rugged terrain, taking more of a risk, but wanting to capture other types of the lunar geology. So grab a look at this picture and look for things like on the full moon, things that are more accentuated are the difference in the rocks. So the basalt versus the white cratered highlands, we call this. This is primarily made of a rock called anorthosite, which is an aluminum-rich rock. And it's so bright and reflective because it's made out of a lot of very shiny crystals. So if you look at a granite countertop, it's got a lot of large, flat, shiny crystals. And it's the sort of thing you get in an anorthosite. And then you get some of the larger craters that are more recently impacted on the moon. They've sprayed these ejecta blasts of streams of material away from the crater, and those have fallen over top of some of the older, darker mares. You get white stripes on the dark mare, and you can find a number of craters that have these concentric ray systems around them. And one more, I'll leave you with two little things to look for, is if you head up here to Mare Crisium, and you look for this bright crater that's just to the west of Mare Crisium. There's a ray system coming off this crater, but it's actually asymmetric. So the rays only go in about 180, maybe 200 degree of a circle around it. There are no rays on the bottom side. And that's because we think the object that caused this came in from this direction, blasted the moon, and then threw all the material ahead of it one way. So ray systems are very prominent during the full moon. The bright and dark mare are very prominent. And you can also look for places where craters have punched holes in the dark mare to produce these little white spots. So the mare are actually overlaying the whiter rock. And when you punch a hole through that, you can see the white rock through the bottom of the basin. So you can get all these interesting
I'm going to jump in with a couple things, Chris. There's one question from Kai, and that was, hold on, where is the South Pole on the moon?
So when we look at the moon, I've got 0, 0. That's would be corresponding to the 0 equator, 0 latitude. So 0 longitude, latitude on the moon. North Pole would be at the top in this picture, and South Pole would be along the bottom in this picture.
And I have one thing that I just wanted to mention quickly, and I'll send out the link in the chat. We're actually, Randy Atwood, who is the past executive director of the RESC and knows a ton about the Apollo missions. He's going to be talking about Apollo 13 on Monday night, which is the 50th anniversary of when that big disaster happened. And so it should be really interesting. If you would like to come to that talk, I'll send out the link in the description. It'll be at 7 p.m. Eastern Daylight Time. There we go.
All right. Yeah, so just back to the full moon tonight. So it's going to be a lunar perigee syzygy, otherwise known as supermoon. So
lunar perigee syzygy. Gee, yeah. I wonder why astrologers chose a better name or a slightly easier to pronounce name. Yeah.
All right, so let me show you some really fun tricks that you can do with the moon. Now, the moon's orbit is actually inclined by 5 degrees from the ecliptic. So let me just pull back here, and I'm just going to plot hitting the letter K, comma on the keyboard will draw the ecliptic. And I'm just going to actually make the daylight disappear by clicking the daylight off button here. And I'm going to wind the time back. You can see that the sun is right on the ecliptic, but the moon is actually riding above it right now. So the moon actually deviates by about 5 degrees above and below the ecliptic. Although at times it actually is on the ecliptic, it'll pass over it, heading north or heading south. And if the sun happens to be at that same spot, that's when we get an eclipse. So what we can do here is I'm just going to wind the time back a couple hours. Let's put this around 12 o'clock. I'm just going to click the sun and center it. And then I'm going to hide the ground. So I've already hidden the daylight. So I hide the daylight. I'm going to take away the compass marks. I'm going to hide the ground as well. And I'm going to also take away my time here. And I'm just going to keep the sun centered by clicking the centering button. And then if I go in here and advance the time, and each time I click, also what I'm going to do is I'm also going to click this to equatorial mode so that this will stay, the slope will stay fixed. So I'm just going to keep speeding. Every time I click the right double arrow, it speeds time up a little bit. And eventually things will start to move a little bit. So you can see the sun is traveling along the ecliptic. We talked about why we get, here comes the moon. So see how the moon is going to head past the sun, boom. So right around this time is when we have new moon. So the moon is invisible in the sky because it's hidden by the daylight glare. So if I bring the daylight back on here, I'll turn that off, and I'll keep going. So we can have the moon going by. Now here's that comet atlas that's built into Stellarium right now. Let me just wind this back so we can see sort of what happened with that. All right. All right, I'll let you worry about playing with the comet later on. Right now, I'm just going to stick with the moon. All right, so there's one thing you can do, and that'll show you that the moon is going up and down. Now, eclipses happen when, as I said, when the moon is near the ecliptic at the same time, at the same location that the sun is there, and the next eclipse happening in this neck of the woods. Let me just bring up my list here, is going to be an annular solar eclipse on June 21st. So let's bring up the date.
June 21st this year?
Yep. So let's set this up to June 21st. And I need to put the sun back in the middle again here. All right. So here's the moon. And if I bring this back a couple of hours, now I can see the eclipse should be happening, but that's because I'm viewing the sky from Toronto. So really what I need to be doing is viewing the sky from the place it's visible, which is somewhere around Africa. So if I do this, bring up my map and I put a pin, say, somewhere in Africa here.
Ooh.
This vantage point, the moon comes back, and if I wind the time back, and I'll sort of do a little trial and error here just to get my location pinned down.
So this is similar to what a lot of astronomers do, is they'll go out and hunt down eclipses and travel to these places where they can get the most amount of time with the moon in front of the sun and the best view and the best weather. So for example, with the eclipse that's coming up in 2024, many of our members, even though it's going to be coming right by Toronto, it's going to be a total eclipse in Hamilton, most people are going to Texas because Texas has better weather.
That's right. And it's April. It'll be
Yeah,
April.
April's going to be cloudy.
You can see that I can't make the sun disappear, and that's where the word annular comes in. So this eclipse is happening when the moon is actually near its apogee or farther from the Earth. And that means that it's not large enough to cover the sun. So when it's not large enough to cover the sun, oops, let me just bring back, just dialing down my location a little bit better. When it's not large enough to cover the sun, then it leaves a ring or an annulus of visible sunlight all around it. And again, I'll just wind the time. So there we go. This would be totality during the annular solar eclipse. So you probably won't see the corona the way Stellarium is showing it during a real annular solar eclipse. So people aren't nearly as keen to go traveling to see an annular eclipse. But that's the one that's going to happen. Now, at the end of the year, on December 14th, so let's just jump to December 14th. And I'll wind this back out so we can find the moon. And I'm just going to play with the hours. Oops, December. There we go. So here we are getting close. But this total solar eclipse is actually visible from Argentina. So the southern sort of tip of South America. So if I drop my pin down there, and then I can wind, let's go back about an hour, a little bit more. And again, so you can, yeah, as you said, you can use Stellarium for your survey planning, your observational planning. So I'm just gonna get in here and tweak my latitude a little bit. So you can see that the moon is a lot bigger. And so it's actually covering the sun.
Perfect. And that's usually what a lot of astronomers go for. And that is because of the corona. Oh no, the corona. It's a nicer corona though.
All right, so my Stellarium just crashed. I'm just going to get rid of it, start again.
Well, it's in beta, as we once mentioned. Well, I'll mention briefly about the corona of the sun. It's the outer part of the atmosphere of the sun. And so you can't normally see it because the sun is so bright. But when it's in front, you can see all these really cool details. I wonder if we have a photo. Stellarium should show us.
All right. So one other thing I want to show you before we move on is, let's just bring the moon up into view here, and let's talk for a second about lunar eclipses. So the lunar eclipse happens when the moon is full, it's opposite the sun, but it's lined up so accurately that the moon dips into the Earth's shadow, and no sunlight can reach the moon except sunlight that's refracted around the edge of the Earth. And if you watch the sun as it's dropping below the horizon, the only type of light you generally get is a reddish, golden, orange light. And that's what produces the reddish sort of so-called blood moon effect. So the total lunar eclipse is not going to happen for a while in the Toronto area, but there was a good one last January. Let me just bring up the January total eclipse. Let's go back to January 2019. And it was on the 21st. And let's see if I can get the time set here. Oops. Oops, January 21st at about midnight. So it should be around midnight.
Ooh.
And oops, I got the year wrong. That's my problem. Let's get rid of my ground here for a second.
Ah.
There we go. There we go. So what I'm going to do is I'm going to just pick a star and center it. I'm just going to wind back a couple of hours. And if I play time forward, you can watch how the moon. So the Earth's shadow is invisible. It's around because the Earth is a sphere. It creates a round shadow in space. It's always there. That's why satellites can suddenly appear or disappear when they enter or exit the Earth's shadow, because their sun can't reach them, so we don't see the reflected light off of them. So here on last January, I'll just continue time flowing here. So you can see that the moon is partly into the Earth's shadow or umbra. And if I keep going, now we're getting a total lunar eclipse. And if I advance the time, eventually it'll come out. And early astronomers noted that the shape of the Earth's shadow was round, and that was one of their clues to infer that the Earth was a sphere, even before we had rocket ships and satellites able to prove that.
I also, can I mention briefly too, when you're observing a lunar eclipse, I really like Stellarium for doing this. Oftentimes you'll see photos of that really bright, like that bright red moon. It's actually quite dim, especially compared to the full moon. So it was nice of Stellarium to show us that the full moon was so bright, and that red color is actually quite muted.
All right, one last thing I want to show you with the trick you can do with Stellarium and the moon. So if you center the moon up, and if you hide the sky and hide the ground, and you can set this to equatorial mode, which will keep the moon nice from rocking and rolling and moving around too much. And then if you advance, click a few times to get time flowing. Just get rid of my nebulous here. I'll slow this down a little bit. So what you can notice when you do this and watch it for a while, so you'll be able to see that the moon changes its phase. So this would be if we could make the Earth transparent and just watch the moon 24/7, which we can't, but this simulates that. So we're keeping an eye on the moon night and day as it goes around the Earth. So the angle that it makes with the sun produces the different phases that we see. But you can also see that if you notice, the moon is actually shrinking and growing and shrinking. And that throbbing, that pulsing, is when it's big, it's at perigee, and when it's smaller, it's at apogee. And so the supermoon is the coincidence of the two effects. It's full when it's also close to the Earth, and that gives you the supermoon effect. And the final thing that you see is that the moon actually wobbles and tips a little bit. And that's an effect that we call libration. And that's because that orbit that rides up and down the ecliptic means that when the moon is south of the ecliptic, we can see a little bit over its northern horizon and a few more extra features in the north. And when it's riding the other way, that we can see the south pole of the moon a little bit. And because the moon's elliptical orbit, sometimes it's running a little fast east or slow east, and we can see a little bit around its left and right edge. So even though the moon keeps one face towards us all the time, it's actually possible to see about 56% of the moon's globe if you time your observations just right.
And you just answered about 5 questions in the chat, so thank you, Chris.
Oh, good. Now, one more cool thing I want to do here is I want to take us back home. Take this off. Now, everybody knows, or most people know, that on Earth, we have Polaris. And Polaris points to the Earth's north celestial pole. And as the Earth rotates, the stars do a circle around Polaris. So we call Polaris our pole star. Now, somebody asked me the other day, what about the moon? So what you can do here is you can go to Sky and Viewing Options. You can go to Landscape. You can click on this option that says use associated planet and position. Click on that and then say moon. And now we're actually viewing the sky from the moon. And if I bring up my clock, of course, on the moon, on any point on the moon, you're standing sort of, you know, other than the poles, you get 2 weeks of daytime, 2 weeks of darkness. So let me just advance the dates here until we get some daylight so you can see that we're on the moon. Here we go. So there's the sun in the sky. And so if I bring up my equatorial, my azimuthal grid, then that's showing you, let me just get rid of the comet here for a second. Okay. So we should be able to make, where are we at? We should be able to make the moon's north pole. Ah, wrong grid. I want the, there we go. I want this grid. So the moon's Polaris, if you want to think of it that way, is actually not near our Polaris, which is up here, but it's actually in the constellation of Draco. So if I zoom in here and I pick a star somewhere near there, and I center that star, and then I run time forward, you can see that sort of keeps that spot in the sky and everything else goes around it. So that's the corresponding star for the moon. And every star, every planet in the solar system has its own pole star. So only Polaris is Earth's.
What's
All
down
right.
at the south? What's down at the South Pole?
The south celestial pole. Let's see if we can find that on here. Let's see if I have to hide the ground. So the moon's south celestial pole is near the tip of the constellation Dorado. And did we show the Earth's south celestial pole?
We haven't seen our celestial pole yet.
Right, so let's go back to Earth. I'm just going to go back to Earth. It doesn't matter where. And I'm going to hide the Earth.
And our plan is in the future, as Chris has mentioned, to do a little tour of the southern sky because so many folks don't get to see it. That's
right. So this is the southern hemisphere stars. You can see that there's Crux, the Southern Cross, and we've got Rigel Kentaurus, which is otherwise known as Alpha Centauri. You can wave at the Space Family Robinson. That's where they were going. All right, so the Southern Hemisphere observers, astronomers and sky watchers, they don't have a pole star to use to line up their telescopes, so they have to learn how to sort of figure out where the south celestial pole is by looking at some of the nearby constellations and the star patterns. And so if I advance the time here, you can see that. Whoops, I'll just turn off the daylight. So that's the southern celestial pole. All right, so let's pause. Okay. All right, let's head. I'm just going to now one sort of tip for everybody. If you really mess up your settings in Stellarium, or you go somewhere else, you're not sure how to get back, the best thing to do is just exit the program and restart it, and it remembers your settings and it brings you back up.
I'm going to briefly, while that restarts, address some questions. There've been a ton of questions about constellations and the number of stars on constellations and how many, count for a constellation. And I just wanted to mention that while there are sort of like so a lot of this stuff is just made up, right? Like these stars are not, they're not all close together in space. They look close together from where we are. And so it's made up by people from a long time ago. And the constellations have also changed. There was a constellation called Argo that was gigantic. It was a ship, and they split it up in the southern hemisphere, and they split it up into 3 because it was just taking up too much space. So if you want a list of stars that are in constellations, you can go to Wikipedia, and it has a list of every star that's in the constellation, bearing in mind that not all the stars are part of the little stick figure that you see in the sky here. They just count as like what's in that part of the sky. Is that all? Do you have anything else that you would want to add to that, Chris?
Well, one of the great things about Stellarium, and I'm so glad you asked this, is that if you go into the Sky and Viewing Options window, and then you go over to Star Lore, then what you've got here is this is where you control how the constellation stick figures look, how their labels are, and so on. You can add the art as I mentioned last week. So you can add the artwork. But what you can do is you've got a long list of other ways of illustrating the sky. So every culture in the world has, basically seen their own versions of patterns in the sky, what they believe they are. Orion is very commonly seen as a big human figure. So that's very common amongst the different cultures. And I'll go back to Regulus, to Leo in a second here. But if you pick some of these other cultures, then you can see their representation of the same thing. So we're showing you the sort of standard 88 Western constellations used in Western astronomy. But if you wanted to say, look at the Ojibwe constellations, then you'll get the name. This Bibuni Kionini, which is the Winter Maker constellation, is what their interpretation of Orion was, except in their thinking, they actually had Orion's arms stretch out to end at his hand at Procyon, the bright star Procyon, and his other hand reaches out and grabs Aldebaran in Taurus. So you can see he's got, compared to Orion, he's got long outstretched arms.
And then
or we can go to,
since we're talking about Ojibwe constellations, I am just going to briefly mention that in Ojibwe culture, you typically don't talk about the constellations when the snow is not on the ground. And so I just wanted to make that acknowledgement while we are here.
Yeah, they reserve or preserve their stories for the appropriate time of the year. So you would not talk about the winter constellation at this time of the year, or once he's gone. You might have stories about the summertime constellations. That's right. The other interesting thing is, and we will get into more about this maybe in a future session, but the artwork that Annette Lee has created for the Stellarium indigenous constellations, you might have not have noticed or realized, or you will once you start playing with this, is that these figures show the internal organs of the human body or the animals that it corresponds to. And that is conveying the aspect that the spirits in the sky can see right into our hearts. They can see into our souls. And so to them, we're transparent beings. All animals and people are transparent beings. So they represent the constellations the same way as sort of semi-transparent beings that you can see into.
And one last tiny bit is that Annette Lee and several other contributors wrote a book about Ojibwe constellations. And so if you'd like to read about it, we do sell it in our online store. And so it's available for purchase along with a planisphere that has, hey, there it is. Thank you, Chris. Along with a planisphere that has Ojibwe, Lakota, Dakota, Innu, and Greek constellations, different wheels for each one.
That's right. Let's just, so in China, there are more than 200 constellations. They break the sky into much smaller segments. And what's interesting about Chinese astronomy is that they believe that the part of the sky around Polaris, which is here, is the heavenly palace where the emperor goes in the afterlife. So the constellations towards the North Celestial Pole would all be composed of elements of the heavenly palace. So the palace courtyard, the walls, the things you'd find in a palace. And the farther away you go from Polaris, the lower in caste that you go. So you'll get into the merchants and their tools and trade items. And then eventually you'll get to the peasants, the farmers, the farm implements and things like that. So it's kind of a neat, different understanding of the sky. And let me just look up the Inuit here. Should have the Inuit. So here's the North American Inuit. And you can actually, there's a switch here. And under labels, you can choose the native name or the translated name. So here's the English expression. So the Big Dipper, they call it the caribou. And the V of Taurus, they consider to be the sled dogs sort of surrounding and menacing Aldebaran, which is representing the polar bear. so in their culture. So it's a bit of a different idea. So it's really fun to sort of dive into Stellarium here and just sort of look at the different cultures that you have available to you. All right, so how's our time? Maybe we should take a
We
few
have
more
15 minutes,
questions.
yeah. So I will mention now that we're probably not going to talk about Mars this session. We'll talk about Mars at another session. The reason we had it on the schedule was because Mars is going to be bright and beautiful and at opposition in October. So that means it's going to be, we're going to be between Mars and the sun. So it's going to be as close to us as it gets during its orbit. And therefore it's going to be really nice to see. But that's October, so we have some time, whereas the supermoon was tonight. So on that note, let's take some time for questions. We don't have a ton of questions that have popped up throughout the talk so far. One question, but if you have more, please add them to the chat. Or sorry, not to the chat, the Q&A section. From Gail, does every planet turn around its own axis as well as travel in its orbit around the sun?
Yes, yeah, the short answer is yes. One of the neat things you can do in Stellarium to show that working, and I'm so glad you asked that. So if I'm going to bring this back to now. All right. So if I go to this, use this trick that I used a little while ago under landscape, and I say use associated planet, and I say go to the sun. So now I'm viewing the solar system from the vantage point of the sun. And if I pick a planet, so let's see if we can find ourselves a planet here. I'll use my search tool. And again, as I say, you can try some of this at home. So if I were to pick the moon, and I have a method for doing this. So here's the moon. So the moon is viewed from the sun. If you watch the moon over many, many days, you can see that the moon, and let me just put this into ecliptic mode so that's easier. You can see that every day, oh, let me turn off the daylight for the sun here. There we go. That is viewed from the sun, the moon does rotate. A lot of people think that because the moon faces the earth, keeps one face towards the earth, it doesn't rotate. But if you think about it, it's rotating once around in the same time it takes to orbit once around the earth. And so viewed from the sun, outside sort of the frame of reference, you can see that the moon is orbiting around. And so I could pick any planet. I could pick Mars and do the same thing. And you can, I'll let you do some of this.
What's that? Sorry, Chris, what's the, you know how the moon always on one side always faces us? What is that called?
So generally we call the side facing the earth the near side and the side facing away from us the far side. A lot of people think of the far side as the dark side, but there's always one half of the moon lit and one half of the moon dark. And that's not always the far side that's dark. So I prefer to teach people to use the word near side and far side.
I was trying to get you to tell us what tidal walking is.
Tidal, oh wow, we can talk about
Sorry,
tidal
Chris.
walking. So let me just advance this. You can see that you can see Mars rotating preceding the sun. So when the moon was first, we think that the way that the moon was first formed was in the early solar system, there were actually extra planets, planetoids, planetesimals, different size objects. And at some point in the process, early in the solar system, an object the size of Mars smacked into the Earth. And it was a glancing blow, so it wasn't sort of a destructive thing. It was more of a glancing blow that actually blasted off a lot of the Earth's crust, peeled it off. And that material then went into orbit around the Earth and formed a ring for a while. And actually within a very short time, I've even heard as little as 100 years, the debris in that ring coalesced into the moon. And so that moon would have been hot and molten in the beginning, but eventually it would have cooled down. And the freshly made moon would have been orbiting the Earth, and the Earth would have been spinning, as all planets, when they are first formed, they have a spin that they retain throughout their their life, their existence. And that moon would have been spinning also. So at the early times, if you were able to be on the Earth, you would have seen the moon's rotating. So you would have seen all the sides of the moon from the vantage point of the Earth. But because the Earth and the moon are exerting gravitational attraction towards each other, the gravitational attraction actually causes the material in each of those two objects to try to get to the other one, to draw towards the other one. And that's what we call tidal bulges or tidal forces. On the Earth, we have water, which is certainly able to move around. So the Earth's ocean tides are caused by this gravitational tug of the moon and to a lesser degree, the sun. And what happens is that the tidal bulges of the two, the Earth has a tidal bulge from the moon and the moon has a tidal bulge from the Earth. And as those two objects are revolving, rotating, the bulge finds it difficult to migrate around the planet. And the end effect of it is if you were to say, have two people standing there and put your hands out, and as you spin, hit your hand, you kind of slow each other down. Let's say you're ice skaters, you got yourself turning, but if you're able to sort of slap each other's hand, the lighter person would stop spinning on the ice faster or sooner than the heavier person would. And that's because of the inertia. So the moon, the Earth has stopped the moon from spinning more than once per month. And eventually the moon will stop the Earth spinning too.
Ooh.
And all of the major moons that are orbiting planets in our solar system all have had sufficient time to become tidally locked to their planet. So Phobos and Deimos keep one side towards Mars. Charon keeps one side towards Pluto, and all the main moons, Europa, Ganymede, Callisto, Titan, all of those moons in our solar system are tidally locked to their home planet. So eventually everything sort of slows down, locks into place like that.
So sorry, I just want to clarify because this is new for me. Will every moon eventually, given enough time, and assuming nothing else terrible goes wrong, will every moon become tidally locked?
Yeah, I think so. There's actually a formula, sort of T equals, and a bunch of things that have to do with the relative masses of the orbiter and the orbitee and all that sort of thing in the closest, but yes.
Cool. Are you ready for other questions? Were you going to
Sure.
talk about Mars? Okay. This is a relatively simple question. This is back on constellations. We're doing a little bit jumping around. What is the difference between constellations and asterisms?
Ah, good. Okay. So let's go back to Earth here.
Also, hello from Sudbury. I was near Sudbury. No, I wasn't. I was here in Toronto the whole time.
I'm back. Let me just start this up again, just so we reset. What's nice about Stellarium is that you can stop and restart it so quickly. So it's works out
Not
great.
too bad. Sorry, repeating the question, because someone heard the question as Stellarium gets started up again. The question is, what is the difference between constellations and asterisms?
Right.
And then I muttered a bit about Sudbury. Sorry, yes. And Shoshana also just pointed out that I talk fast, and I apologize for everyone. I know I talk fast. I try really hard to slow down sometimes, and I forgot this time. I apologize.
Okay. So let's talk about the Big Dipper. So as I said a little while ago, there are actually 88 official constellations that cover the sky. Each has its own boundary, no overlap. And so the Big Dipper is actually within this boundary defined for the constellation Ursa Major. Ursa Major is Latin, it means the big bear. You can see that the bear is actually composed of the torso here, its nose, front legs, back legs, tail. It's not really tail. We can talk about the indigenous stories. Jenna told the story last Thursday about the stars that follow the Ursa Major. Let's just bring up the illustration. So Ursa Major is a constellation, but the Big Dipper is an asterism. So an asterism is an informal pattern of stars. Let me just turn off the other ones here. So you can see that an informal picture you can make out of stars that could be part of a bigger constellation or could be made from a set of adjacent constellations, or even it could be a little patch of stars that you zoom in on and you see a pattern. And actually, one of the questions in our mission to scavenger hunt has to do with an asterism that you could see in binoculars or a telescope. So I won't say any more about that right now.
Okay.
So yeah, so an asterism is basically fair game. In the case of Ursa Minor, the constellation is also the asterism. In the case of Ursa Major, the Big Dipper is the asterism inside the bigger constellation. In the case of, let me see if I can bring us up to, let's go to the summer. Here we talked about the big winter hexagon. So there's a big winter football or big hexagon that's made out of 1, 2, 3, 4, 5, 6 constellations. And just by connecting the dots of the bright stars from Sirius, Rigel, Aldebaran, Capella, Pollux, Castor, and Procyon, you can make an asterism. So you're welcome to go out and create your own asterisms and try to make them go viral.
And I think we probably have time for maybe 1 or 2 more questions. The question that stands out to me now is, why do high tides occur on the side of the Earth facing the moon and the opposite side of the Earth as well? And I'm not going to answer this, but I'm a marine biologist by training, so this is the one that really appeals to me.
It's been a while since I remembered all my facts about tides, but essentially what you're doing, when 2 objects mutually attract one another, you're dealing with their center of mass. And so the moon's pull on the Earth actually creates a center of mass of the 2 objects combined. And that center of mass is no longer, of the Earth-Moon system is no longer in the center of the Earth. It's actually displaced towards the moon. And so that can have the result of, first of all, the material on the Earth's surface closest to the moon being pulled. I should back up. Gravity is increased by minimizing the distance between the 2 attractive bodies. So it's inversely proportional to the separation of distance between the 2 bodies. So the parts of the Earth that are close, that are pointing towards the moon or closer to the moon, they get pulled a little harder by the moon and they rise up. And then the opposite side of the Earth, you get a bulge going the other way because the center of mass of the Earth-Moon system has been offset towards the moon a little bit. And it can't pull on the backside of the Earth as strongly. So it can sort of swell up and move away a little bit. That's hand wavy, but you get that. On top of all that, you also get the sun creates tides on the Earth as well. And so the terms neap tide and things like that, they have to do with the combination of the sun and the Earth, the sun and the moon, both creating tides on the Earth.
Mm-hmm. So when you're at a full moon or a new moon, theoretically the tide is the highest because the moon and the Earth are both pulling in the functional same direction. Either they're both pulling sort of with each other.
Yeah, it's additive. Yeah.
On either side of the bulge. But if my face is the Earth and the sun's over here and the moon's right here, the moon's pulling this way, but the sun's pulling that way. So it's just not as strong because they're not working together.
That's right.
And so you get lower tides because it doesn't have as much force to pull the water that the rest do. Technically speaking, I think the actual Earth moves a tiny, 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 tiny bit, doesn't it? Because the Earth is kind of swishy.
Oh yeah. It's not just the water on the Earth that moves; it's also the Earth itself. So we do get. So I'm a geophysicist, and one of the jobs that geophysicists do is we go out and we measure the Earth's gravitational force from place to place. So if we want to know if there's a buried mineral deposit, and minerals tend to be heavy and massive, we can do a networked grid search pattern measuring the Earth's gravity in the area we think those minerals are, and we actually have to reduce the data set, correct the data measurements we take for the effects of tide, because it'll actually our elevation will change during the course of our measurements. So we have to account for all of those fine differences.
I have an extra question. I know we're almost out of time, but it's from Shoshana in the chat. But right before that happens to Rick Stankiewicz? Something along those lines. I apologize, Rick. Mentioned that shape of coastlines also affect tides. And as a marine biologist, this is where I can jump in and say, if you've ever been to New Brunswick and the Bay of Fundy, the reason the tides are so high there is because of the natural frequency. So it's essentially like if you sit in the bathtub and you rock back and forth at the right time, you end up making a tiny bathtub tsunami. and spilling water all over the floor and upsetting everybody in your household. And that's essentially what's happening in the Bay of Fundy, is that it's getting into the right rhythm and it's getting super high at one point and super low at the next. And it won't last forever, especially since the coastline changes over time, and it'll eventually not hit that same natural frequency.
Yeah.
Yay for, don't try that bathtub experiment at home, kids, because your parents will be mad at me.
But the cool side to all of this is that the tides that the fishermen need to deal with and marine biologists need to deal with, they're astronomical phenomena.
Yes, that is very cool. It's happening from space.
All right, we should introduce everybody to the mission questions.
Yes. Sorry, I just had one super tiny last question.
Yeah.
If you're able to, are volcanoes and earthquakes affected with by the pull of the moon or anything like that?
I don't think to much of a degree they would be, no. The earthquakes and volcanoes are tied more to the plate tectonics of the earth and the building and release of strain at those boundaries, because the boundaries are not free to sort of slip and slide past each other. You get them sort of catching and then releasing with a jerk, and that will give you an earthquake. But I imagine that a tidal pull could be the straw that breaks the camel's back, so to speak. If there was a built-up pressure that was ready to tip over, ready to give, then certainly a tidal force might be the trigger, just to give it that extra strain and stress that triggers it. But generally speaking, no, I don't think we could say that that's true. Okay,
it'd be interesting to see the data on what lunar cycle, or what point in the lunar cycle these sort of things tend to occur, but I don't have that off the top of my head. Anyway, we have answered a good number of questions. There was one last question, which was, will I be able to watch this episode again? And you will. It is live streaming to our YouTube account right now, and you can go and check it out afterwards. I'll just send the link to the YouTube channel in the chat. There it is. And now on to homework for tonight.
So if you go to astrogeo.ca/skylights and look for the newest post.
I just sent out the link.
Yeah, there's your mission 2 questions. Click on in there. And again, as I said, you can right click and save this picture of the moon if you want something to sort of see in high res. And just for fun, I put this picture of the Orion sword that my friend Rick Foster took. We talked about Orion last week, and then there are your mission 2 questions. So please don't post your answers in the comments section of the blog. Let's save everybody's, let's save them so we can go through them together on Thursday afternoon.
Perfect. Okay. I think that wraps everything up. Thank you, Chris, for answering so many questions and covering so many topics and focusing on the moon. And next time, what are we focusing on? I've lost track. We're going to go over the answers to the questions.
I think on Thursday, we probably planned to do more Q&A and to answer the questions. And then maybe what we'll do is, if we have time, we'll preview what events are happening in the sky for the next couple of weeks, since we'll be having a break, right?
Yeah, sounds good. Yes. So just a heads up for folks, is next week, not Thursday. Thursday, we're still going to have Chris, but next week we're doing a special topic, which is astrophotography. So the Tuesday session is going to be with an amateur astrophotographer telling you how to get into astrophotography with either just your phone or a DSLR. And the Thursday session will be about intro Photoshop. So if you have anybody who's interested in those, tell them to sign up for next week. Thursday will be our last session this week with Chris, and then Chris will join us again the week after that. We're giving him a little bit of a break.
In the meantime, send me some more suggestions of things you want us to focus on. We're happy to talk about what you're interested in.
Yes, we want to adapt to what you guys want. Thank you all so much for joining this time, and we'll see you on Thursday.
Keep looking up.
Keep looking up. Answer those homework questions. We'll see you later. Take care, guys.
Bye.
Bye.